Okay, so we have studied one-to-one, on-to. Next we study bijective function. See, bijective function. A function f from set A to set B is said to be a bijective function. Bijective function if f is both one-to-one and on-to. See, f is both one-to-one and on-to. This question was asked, definition was asked in one of the earlier question paper. It is actually, say, question paper problem. QPP means a question paper problem. This same definition was asked. Define a bijective function. See, strictly you have to give the definition like this. Simply don't write function is bijective if it is both one-to-one and on-to. It is not correct. So you have to give the correct definition for one-to-one and on-to function, both one-to-one and on-to. That is, give the correct definition. A function f from A to B is said to be a bijective function if f is both one-to-one and on-to. See, for example, look at this. We consider elements of set A and B under f, A, B, C, 1, 2, 3. See, A going to 1, B going to 2, C going to 3. This is both one-to-one and on-to. One-to-one, why? Distinct elements have distinct images. Why on-to? All the elements of set B are images. Therefore, this is both one-to-one and on-to. So, a function, if it is both one-to-one and on-to, then it is called bijective function. So, please remember, a function f from A to B is said to be a bijective function if it is both one-to-one and on-to. So, you have to remember this definition. Please write down the definitions once or twice, because when you write this was asked in the question paper. When you write the definition in an examination, even spelling mistake should not be there. Complete definition must be given, okay? Because we have to give the definition in such a way that we have to understand the meaning of that. So it must be a meaningful expression. Now let us solve problems on this concepts one-to-one, on-to and bijective. See, first problem, show that the function f from n to n given by f of x equal to 2x is one-to-one but not on-to. See, question was asked in the previous question paper. It is both one-to-one but not on-to. See, I will explain it with the help of one or two methods. First, from exam point of view. This is only by using our set theoretic definition. See, they have defined f from n to n given by f of x is equal to how much? 2x. F of x is equal to 2x. Now, first case, I am writing let x1 comma x2 belonging to n. Which n? There are two n here and here. This is domain, this is codomain. You are finding out x1 and x2 in the domain set. So this n means it is a domain. This is for your information. Okay, x1 comma x2 belonging to n. Then let us write f of x1 equal to f of x2. What does it imply? It must imply that x1 is equal to x2. See, that is the definition of one-to-one. What is the definition of one-to-one? F of x1 equal to f of x2. That means x1 is equal to x2. That is the definition for one-to-one. So you have to now read the problem. What is f of x? 2x. So what is f of x1? 2x1. What is f of x2? 2x2. This implies x1 is equal to how much? x2. Therefore, what is the conclusion? f is 1 to 1. Function is 1 to 1. Why? F of x1 equal to f of x2 means 2x1 is equal to 2x2. Therefore, x1 is equal to x2. Hence, f is 1 to 1. Then, you go to this onto definition. What is that onto? See, we have already written for all y belonging to n, we write f of x is equal to what? We write f of x is equal to y for all that. So, we directly write let f of x equal to y. How do you write this? We have defined for in the case of onto, for all or for each y belonging to n codomain, there exists an element x belonging to the domain such that f of x is equal to y. So, let us write f of x is equal to y. What is f of x? 2x, that is equal to y. Now, that is, what is x? Y by 2. All of you try to understand. Onto means, I repeat, what is onto? For each y belonging to codomain n, there exists x belonging to domain n such that f of x is equal to y. So, first you have located an element in the second set, that is you are taking f of x is y. Now, with the help of this you are finding an element x that must belong to this domain. Now, I have got x is equal to y by 2. Does it belong to this n domain? No, it does not belong to n. N means domain. See, I am just writing this domain, that is for your understanding. Always you should remember that onto means for every y belonging to the second set, there exists x belonging to the first set such that f of x is y. So, now you have located an element in the second set. Hence, you are finding out an element x in the first set. But after locating this, after taking this second element of the second set, you have got x, but it is not belonging to n. Why? X and y all are natural numbers, they belong to n. Suppose if y is 1, x becomes half, it is not an element of n. Therefore, f is not onto. So, theoretically we prove the problem like this, but we have to understand better. See, now just or, this is for your understanding. See, we just consider this a diagrammatic method, n to n. Now, we have 1, 2, 3, 4, 5, etc. 1, 2, 3, 4, 5, 6, 7, 8, etc. See, they have given f of x is equal to 2x, x is 1, f of 1 is 2, x is 2, f of 2 is 4, x is 3, f of 3 is 6, x is 4, f of 4 is 8, then x is 5, f of 5 is 10. What do you find? Distinct elements, 1 going to 2, 2 going to 4, 3 to 6, 4 to 8, 5 to 10, similarly 6 to 12, 7 to 14. So, it continues. So, what is your observation? That is, all these elements, say element set n, that is distinct elements will be having distinct images that are in our own language. What is the meaning of that? One element should go to only one element. This is how we have to understand. So, here 1 is going to 2, 2 going to 4, 3 going to 6. Therefore, each of these elements they are going to a single element there, or distinct elements have distinct images. Okay. But what about this onto? See, here I have written f of x is equal to y. Theoretically, I have defined. I have just found, identified an element y in the second set. Thus, I am getting x, but it is not belonging to n. So, actually, what do you mean by this? See, why it is not onto? It is very clear now in this case. See, look here. What is the definition for onto? What is the definition? All the elements of this is the codomain set, right? All the elements of the codomain set are images. But here 1 1, 3, 5, 7, 9, etc. Odd natural numbers, are they images of any elements of set domain set? No. Therefore, it is not onto. So, why it is not onto? Because here we find odd natural numbers are not images. Okay. See, F is first case, F is 1 to 1, that is 1, F is 1 to 1. Now, why it is not onto? See, numbers, or you can write odd natural numbers of the codomain set are not images. Therefore, F is not onto. So, why it is not onto? Because odd natural numbers of the codomain set are not images. So, it is not onto. Now, prove that the function f from R to R given f of x is equal to 2x is 1 to 1 and onto. See, observe the difference between this. There it is the same problem, but one difference. The function is defined from n to n. Here I am defining from R to R. R to R means real numbers. Okay, it is defined from real numbers. So, f of x is equal to 2x. Now, first see, they have given f from R to R given by f of x is how much? 2x. F of x 2x. Now, tell me, what is 1 to 1? How do you verify 1 to 1? For all x1 comma x2 of the domain set, f of x1 equal to f of x2 should imply x1 is equal to x2. So, I am writing, let x1 comma x2 belonging to R. What is that? Domain belonging to R. Now I am writing f of x1 equal to f of x2. What does it imply? What is f of x1? F of x is 2x, no? What is f of x1? 2x1. What is f of x2? 2x2. So, x1 is equal to x2. Yes, it satisfies the definition. Therefore, f is 1 to 1. Now, second case, for onto, for each y belonging to the codomain, there exists x belonging to domain such that f of x is equal to y. So, I am writing, let f of x is equal to y. Now, tell me, what are you supposed to prove? Anyhow, you are just assigning, or you have located, I found out an element y in the second set. Now, you have to find an element x that must belong to the domain set. It is enough if you show that this x belongs to R. That actually defines the onto. See, this implies, what is f of x? F of x is 2x. 2x, correct? 2x is equal to y. Therefore, what is x? Y by 2. Does it belong to R? Yes, it belongs to R. That is, this R is domain. Okay, this R is domain. See, here x is equal to y by 2 belongs to R, because R means real numbers. It includes all natural, integers, rational, irrational. So, this is a rational number. So, for all y belonging to this codomain, definitely y by 2 also belongs to R. So, x is belonging to R. Therefore, f is onto. Okay. Why this is onto? For y belonging to codomain, I can find x belonging to the domain such that f of x is y. Therefore, f is onto. Hope you have understood the idea. So, problems are almost similar, but look at the way I have defined. There the function is defined between, in the previous case I have defined the function from n to n, but in the present problem I am defining it from R to R. So the function is both one to one and onto. Such a function is also called bijective function, isn't it? Both one to one and onto, they are called bijective function. Example, say show that the function f from n to n given by f of 1 equal to f of 2 equal to 1 and f of x equal to x minus 1 for every x greater than 2 is on to but not 1 to 1. See, this question was asked in f of x is x minus 1 for every x greater than 2. In the problem itself they have given, it is not one to one. Why? See, they have defined f of 1 equal to f of 2 equal to 1. So this implies f of x1 equal to f of x2 implies x1 not equal to x2. See here, f of 1 equal to f of 2, that is this much. See, we have f of 1 equal to f of 2. So both the values are equal to 1. Their images are equal. That is, f of x1 equal to f of x2 implies x1 not equal to x2. Why? Here can we have 1 equal to 2? No. Actually, what is one to one definition? F of x1 equal to f of x2 should imply x1 is equal to x2. But here we cannot have 1 equal to 2. Therefore, f is not onto. F is not onto. Second case, let f of x is y. Generally, for proving this onto function or verifying onto function, we always find an element y in the second set, such that there exists an element x in first set, such that f of x is equal to y. So that implies, what is f of x? X minus 1, or that is x is equal to y plus 1. X is equal to y plus 1. See, they have given x is greater than 2. Okay, x is greater than 2. Okay, let x be equal to 3. 3 plus 1, 4. It belongs to n because it is there. N means natural number. 4 plus 1, 5. 5 plus 1, 6. So all these elements, they belong to n. Therefore, f is onto. Or you can also work out like this. See, even this is possible. Let us consider this. That is n to n. Okay, f. What do you find now? These are the elements. 1, 2, 3, 4, 5, 6, 7. Now they have given 1 to 1, 2 to 1. They have given this. See, f of 1 is 1. F of 2 is 1. They have given f of 1 is 1, f of 2 is 1. So next, x greater than 2. Look here, x greater than 2 implies f of x is x minus 1. So this is actually defined for what? This x function f of x equal to x minus 1. It is defined for x greater than 2. So you write x equal to 3. So what is f of x? 2. X is equal to 3. What is f of x? 2. So 3 to 2. Similarly, 4 to 3, 5 to 4. If I write 6 to 5, 7 to 6. So we observe that all the elements of the codomain set, they will be images. Okay, see, you just observe this, but it is not onto. Why it is not onto? Because definition of onto is distinct elements have distinct images, but is it like that? 1 and 2, both of them are going to 1. So, f of 1 equal to f of 2 implies their images are same, but that implies x1 is not equal to x2. Therefore, this is not 1 to 1, but this is onto. So, generally in the exam, see, 1 mark for verifying 1 to 1, 1 mark for verifying onto. Hope you got the idea. Show that the function f from R to R defined as f of x is equal to x square is neither 1 to 1 nor onto, neither 1 to 1 nor onto. The function f from R to R defined as f of x is equal to x square is neither 1 to 1 nor onto. Now, look here, just give the definition. See, f of x is equal to x square. Very simple. First, let me write what is f of 1, 1, and what is f of minus 1, minus 1 square, 1. Correct? So, here f of 1 equal to f of minus 1 equal to 1. That is, f of x1 equal to f of x2 implies x1 not equal to x2. Why? F of 1 is 1, f of minus 1 is also 1, but what do you find? F of 1 equal to f of minus 1, both of them are equal to 1. According to definition, what must be, I mean, say, what is the inference? What is actually it is we are following here? According to definition, f of 1 equal to f of minus 1 should imply 1 equal to minus 1, right? But is it possible or is it true? No. Therefore, this shows f of x1 equal to f of x2. That means x1 not equal to x2. So, what the conclusion? F is not 1 to 1. F is not 1 to 1. Actually, we can also write, see, graphically, f of x, x is 1 minus 1, that is 1, plus 1, that is 1. Now, what about this second case? How do you verify onto function? How do you verify onto function? See, let f of x is equal to y, correct? That implies, this implies, what is x? What is x? F of x is x square, that is equal to y. That is, x is equal to root of y. What is x? Root of y. Does it belong to R? If y is a positive, then obviously root y belongs to R. But y is a real number, so y can take negative value also. Therefore, it is not belonging to R. Therefore, f is not onto. F is not onto. So, thus we can give the conclusion. The function is neither 1 to 1 nor onto. The function is neither 1 to 1 nor onto. So, is this idea clear to all of you? So, 1 to 1 means always, what is the meaning of 1 to 1? Distinct elements have distinct images. Because with the help of a definition, we can't just solve the problem. So, we need the expression f of x1 equal to f of x2, that implies x1 is equal to x2. Then the function f is 1 to 1. And for onto, all the elements of set B are images, that is the definition. But for all y belonging to the codomain, there exists a corresponding x belong to domain such that f of x is equal to y. So, for finding some y in codomain, x must be in domain. But here you are finding an element y in codomain, but corresponding x is not belonging to domain. Therefore, the function is not onto.